Good morning, boys and girls, and welcome back. Mr. Murtara here, and today we're going to talk about graphing logarithmic functions, right? Well, two things. We're going to talk about graphing logarithmic functions, and we're going to talk about finding the inverses of logarithmic and exponential functions, kind of building off what we were talking about yesterday with changing forms between the two, all right? So kind of two separate topics. We're going to start with the inverse discussion, and we'll have that lead into our discussion about how to graph logs. All right, so let's zoom in here. We found inverses in the last unit, and we know that to find the inverse of a function, the very first thing we should do is change our x and y. So that's what we're going to do. I'm going to replace the y with an x, log base of 3/2 y. All right, now we know that the next thing we need to do is solve for y. Our issue is with this, we can't really algebraically solve yet for y. So what we're going to do is we need to change forms. And so going back to yesterday's discussion, when you change forms, you want to start with the base, all right? The base of your log is going to be the base of your exponent, okay? This is in log form. I'm trying to go to exponential form. So the base of my log is the base of the exponent. So this becomes 3/2 is my base. Now, the way I always think about this is, I always want to make it like 3/2 to the y, since that looks like a base and an exponent. But I remember that's wrong. That is too easy. Don't take the easy way out in life. The exponent has got to be the thing that's on the other side of the equal sign. So this becomes 3/2 to the x, and then equals whatever you were trying to take the log of. We call that the argument, okay? And that equals y. And so now I put this into exponential form. And you notice that when I've done this now the y is all by itself. So yay, we did it. And so now I could write that, hey, y inverse is 3/2 x, 3/2 to the x power. All right? So that's how we're going to find the inverse. Okay, moving on to number 2, same thing. Step 1, we need to change the x and the y. All right, once you've changed your inputs and outputs, once you flop those, now you need to go ahead and get the y by itself, right? And again, so we said the way we are going to do this is you need to change forms. In this case, now I'm in exponential form, so I need to change this to log form. And the base of your exponent will become the base of your log. So this becomes log base e. And like we discussed yesterday, we never really write log base e. Log base e is really written as ln, or natural log. So now I've got the log base e, or natural log of, and again, we were just playing on this side over here with the e, so I don't want to mess with that side. That's the easy side. I got to go to the other side. ln of x. I got to go to the other side of the equal sign. Okay? So ln of x equals y minus 4, whatever was in the exponent. All right? And so now I've gotten that y out of the exponent. So now to solve for y, I can just add 4 to both sides. And so we get, hey, y inverse is ln of x. And again, I added 4 to that side, so ln of x plus 4. And so that would be the inverse of this function right here. All right? Point being, again, what we're trying to emphasize here a little bit is like logs and exponents are inverses of each other. Logs and exponents, they undo each other. Okay, that's what inverses mean. Okay, so I'm going to quickly roll through these last two here. Again, step 1 for number 3, change my x and y. Once you flip your x and y, now you need to change form, so I'm in log form, I got to go to exponential form. The base of the log becomes the base of the exponent. This becomes 7 to the x, again, not to the y, equals y. And again, now y is by itself, so that is the inverse. Easy peasy lemon squeezy. All right? And number 4, change x and y. I then need to change forms. If this is in log form, remember ln is log form, it's log base e. So the base of my log is going to become the base of my exponent. And again, it's not like e to the y plus 6 because that's too easy. So it's e to the x, and y plus 6 is by itself. And now I just need to go and get the y by itself. So y equals, or y inverse equals e to the x, and I minus 6 from both sides. So y inverse is e to the x minus 6. And there we found our inverse. All right, beautiful. Now let's talk about graphing. All right, with log functions or logarithmic functions, again, like with exponentials, they have all sorts of different graphs depending on what base you're dealing with, but all of them look the same. So in this case, we're going to start with a base or a b of 3. So y equals log base 3 of x is what we're going to use for our parent function. All right, and if we want to graph this, like we've talked about before, we always like you to plug in -2, -1, 0, 1, and 2, right? For the x's. However, when I do that, what is log base 3 of -2? I don't know. What is log base 3 of -1? I don't know. We can't really plug those things in, all right? So what we do with this to help us is we are going to change forms. Now, again, don't get this confused with the inverses we were just finding before. Because I'm not switching x and y like we did for the inverse part, but I am going to change forms. I'm going to go from log form to exponential form, all right? So this didn't work. Get rid of that. And now when I switch this to exponential form, start with the base to the y equals x, all right? And so now when we plug in, again, it's going to be hard to plug in for the x, but it's going to be a lot easier to plug in for the y. Since logs are the inverses of exponentials, we're going to plug in for the y value instead of the x value. And now again, we're going to plug in -2, -1, 0, 1, and 2 for the y value. And now we can find out what the x value needs to be. All right, so when we plug in -2 for y, we get 3 to the -2nd. Negative exponent sent it to the bottom, so 1 over 3 squared, which is 1/9. Okay, so when I plug in -2, I get 1/9. When I plug in -1, this is 3 to the -1, which is 1/3. When I plug in 0, we know anything to the 0 power is 1. Anything to the first power is itself. And then when I plug in 2, I get 9. All right, so these are the points that we are going to go and graph. So when I plot these now, I got to be careful. 1/9 is the x-coordinate, so I only go over a little bit, and I got to go down to the -2, right? Then I'm going to go over 1/3, so a little bit more, and then I'm going to go down to -1. I'm going to go over 1 and 0. And then I got to go over 3, up 1. And over 9, up 2. So if we look at this, we're going to get a graph that kind of looks like this. And similarly to our exponential functions, okay, we're going to have an asymptote. Only this time it's a vertical asymptote. And it's going to look something kind of like that. So notice this graph is similar to an exponential growth, or at least an exponential function. It has just been flipped on its side, right? Now instead of going up and down, now it's kind of going left and right. What would happen if the b was greater than 0 but smaller than 1? Just like if our base changed, right? If our base was bigger than 1, it was exponential growth. And if it was smaller than 1, it was exponential decay and changed directions. So same thing here. The function would just come from the other direction now. Okay? So it would kind of look like that instead. Instead of approaching the y-axis from the bottom, that's going to approach from the top. All right? The y-axis is an asymptote. In this case, it would be the line x equals 0. Right? That's the way we write the equation of a vertical asymptote. And the domain of this parent function. So now again, because these are inverses of exponential functions, our rules kind of change. Now, this is only going to the right. So that my domain is going to be x is greater than 0. Again, we talked about yesterday, should have anyway, that you cannot take the log of a negative number. Okay, that is undefined. There's this asymptote here is going to run along it, but it won't ever cross to the side. So my domain is x is greater than 0. My range, however, this is going up, and this is going down, so the range is all real numbers. So the rules have changed from our exponential functions to the log functions, and so the domain is now x is greater than 0, and the range is all real numbers. All right, so let's graph another one of these things by hand. Again, you can see the steps above in your notes here, but step 1, you want to write this in exponential form. So my base is 2 to the y equals x, all right? And now, down below here, we have these points that we're going to find, just like we did before for exponentials. However, again, we got to change this. This is wrong there. We don't want to plug in for x's, right? We can't plug in for x's. So what we're really going to do is we're going to plug in for the y values. I'm going to plug in these same numbers, -1, 0, and 1, but we're going to plug it in for the y, so it's going to be easier. When I plug in 1, I get the base. When I plug in, which is 2. When I plug in 0, I'm always going to get 1. And when I plug in -1, I get 1 over the base, or 1/2. Okay? So when I plug in 1, I got 2, 0, 1. When I plug in -1, I flip the base, so I get 1/2. And now I'm going to plot these points on our graph. You just need to remember now that when you plot the points, again, the first number is the x-coordinate, how much you go left and right, and the second number is the y-coordinate, how much you go up and down. We just got done doing exponentials, so sometimes that's easy to get confused. Now, keep in mind again, when we graph logs, they're going to look like this, right? And we're going to have an asymptote at x equals 0, unless things get shifted. So, there's my asymptote. And again, I'm going to start on the bottom, and it's going to look like an exponential growth, but just going to the side. And it looks kind of like that. Our domain is x is greater than 0. Our asymptote was x equals 0. And our range, again, is going to be all real numbers. All right? So there we go. That's how you graph a log. Same idea for number 2 here. I'm going to start by changing my form. 1/3 is the base. F of x is the same thing as y to the x. And now I'm going to find my points, but again, I'm going to plug in for the y's, not for the x's. And you're going to plug in -1, 0, and 1. When you plug in -1, you flip it. 0, you always get 1. When I plug in 1, I get the base, so 1/3. And I want to graph these points. So there are my 3 points. We haven't shifted this anywhere, right? There's no hk, so my asymptote is still at x equals 0. And like we talked about up above, because my base is smaller than 1 now, the only thing that has changed is now it's going to approach the asymptote from the top instead of the bottom. Okay? Just like growth and decay switch sides. So it's going to look something like that. My domain is still x is greater than 0, and my range is still all real numbers. All right? All right, for number 3 here, we finally have an h and a k to deal with now, right? That's going to shift our graph a little bit. Good news, we'll play with h and k's, but we won't play with the a values with logs, although you always could. Okay, but we won't so much in the stuff that we are doing here. All right, so again, same thing. First up, I need to identify my parent function. So ignore the h and k stuff. So in this case, I would get 3 to the y equals x. Now I need to go find my points. To do that, you need to plug in for the y's, and I get 1/3, -1, 1, 0, and 3, 1. Now, I'm going to plot these points. But before I plot these points, I need to shift the origin. In this case, right 1 and up 2. And just like with exponentials, you're going to graph these points off your shifted origin. And once you have your 3 points plotted, then you can again sketch the graph. A nice exponential looking curve, that goes to the side. Your asymptote is now going to be tied to the h value. So x equals 1. And the domain is still going to be all real numbers. And the domain is going to be tied to the h value. So x is greater than 1. Okay? These are now all going to be tied to this h value right here. Okay, number 4, again, ignore your hk. So write your parent function, 1/2 to the y equals x. Now we got to find our points using the y values. And we get 2, -1, 1, 0, 1/2, 1. And then now I need to shift my graph again. Now be careful with this one. This is a k value because it's not in parentheses. If we go back and look at number 3 really quickly, we can see our h values are always in parentheses, okay? The k values are not in the parentheses. So on number 4, be aware that that is a shift down, not a shift right. So because we just shift down 3, our vertical asymptote is still at x equals 0, and now I'm going to plot my points on this new origin. And because our base is smaller than 1, it makes sense that it's starting from this side and growing this way. Domain is x is greater than 0, and our range is all real numbers. And that's what that one looks like. All right, last one. All right, for number 5, we're going to need a calculator because LNs, you got to remember, are log base e. That's a base e. So same idea. I'm still going to rewrite it in exponential form, ignoring the h and k, and then I'm going to find my points by plugging in the y, just like we did before. I would say that when you plug in 0, you should know that when you plug in 0, anything is 0 is 1. And when you plug in 1, you're going to get e, which is like 2.7. So you may not need your calculator for those two things right there. But even I don't know what e to the -1 is. So that's where we're going to need our calculator. And e to the -1 is 0.36. So you can say 0.3 or 0.4. Either one doesn't matter. They're, as far as our graphing goes, it's going to be about the same. Now that we have our points, we need to shift our graph. And again, this is going to be up 2, since that was a k value. And now I need to plot my points. And you're just going to estimate those decimals. Sketch your curve. Again, all logs should be going to the right, the way this one looks here. And then the domain is x is greater than 0. The asymptote is x equals 0. And the range is all real numbers. All right, that's it for today, boys and girls. See you, teacher, if you have got questions. Talk to you later.